Hello, this is a follow me video for the Bouncing Ball project. You'll develop something like this in which all these balls will be moving in a screen. Before you do this follow me video, you should have watched these 3 videos about implementing classes, the concepts, the notation, and the implementation of implementing what's called a class. If you haven't watched those videos already, stop this video, go back and watch those ones, and then come back to this follow me video for the code that you'll write. Assuming that you've watched those ones, go ahead and get the starting code for Bouncing Ball in the usual way. So I'm going to go ahead and accept the assignment. You should do the same. This term is from session 19. And so I'm going into PyCharm and going to clone it in the usual way. For me, good. I will put it in a window by itself just to keep it straight. So go ahead and put the project into PyCharm in the usual way. Here it is. It's got a solution, so you can look back to that if you get lost or anything. And then here's the source code for the starting code. Let's take a quick look at what we'll have. So don't look at the code. Don't look at the code for the solution. But here's what you're going to end up with, a project in which you have all these balls that bounce around, various sizes and colors and positions. So that's what you're going to be creating. Now, what is the obvious type of thing that there are many instances of? Pause for just a moment and think. What is it that there are many instances of? And that type of thing, I hope he's decided, was a ball. So we're going to make a ball class. And then we'll have many instances of ball. In addition, we'll find it convenient to make a balls, plural, class because there are many things that all the balls will do. For example, all of them will draw themselves. And so it's convenient to put those loops that loop through the ball objects into a class of its own, which we'll call balls. So that's where we're heading. Now pause for a moment and think about what a ball object can do. What can a ball object do? Also be thinking about what properties does a ball object have? What are its instance variables? What it can do becomes its methods. What its properties are, or its characteristics, are instance variables. And I hope you've decided that what a ball can do is it can draw itself, it can move, and it can bounce. I think that's about it. It bounces when it hits the edge. As to characteristics, each ball has a radius, a position, an X and Y position, a color. It seems to be most of what it has. We'll see that there are other things too. So that's where we're heading. Now, here is the starting code. Let's go ahead and put your name there. So if you haven't already, put your name there. Just remember this is a follow me video, so you just follow along with me. And notice that what we've got here, I'll put it on David that I got help from myself. You should indicate that you got help from me. And then what we've got here at the beginning of the file is all the to-dos, 1, 2, just listed there. And we'll do them per step by step. That's following what's called an iterative enhancement plan. This is an iterative enhancement plan for doing the project step by step, testing at each stage. Code starts out with the usual boilerplate, the imports, size of the screen and color of it. Main here that initializes Pygame, makes the screen, sets the caption, makes a clock, and then the game loop that goes while true. It clicks at clock, checks for and handles events, so far only the quit event, does every cycle actions, none so far, and draws everything. The screen fills the screen with the background and then does a Pygame display update. And in between, it will draw balls. So that's where we're starting. Let's go up here to to-dos. To do 0 was to run this thing and design the obvious class. What should it be? Its methods and its instance variables. So we just did that. Absorb the starting code. We just did that. And then it says to implement a ball class with stubs for its methods, init, move, and draw at this point. Construct a single ball. So we go over here to our source folder and we right-click and make a new Python file. New Python file. That was on the source folder. We right-click, new Python file. And inside there, we'll call it ball with a capital B. We use uppercase letters for our class names and for the files that contain our classes. We'll follow the Java style in which there is exactly one class per file. So we should add that to Git when it asks. Add that to Git. If you didn't do that, that's okay. You can easily add it later. And we're to make stubs for its methods. So the notation is that we start with a class, the word class, and then the name of the class, ball. And then inside there, we make a def. Well, it's already written part of it for me. I'm going to take away the screen for the moment and just have a pass there. So that's what's called a stub. It doesn't do anything. It has the method name underscore underscore init underscore underscore. Make certain you get exactly 2 underscores on each side and that you spell init with that 2 I's in there, I-N-I-T. If you spell it wrong, you'll have troubles. It takes as an argument self, as do all of our methods in our doing things. Methods that don't take it self can exist, but we won't do them for quite some time. And then we're going to have a draw method that takes self, so far just self, and passes, and a move method that takes self and just has pass. So there's our stubs. So you should get that to work in your code. And you can run moving ball. I should have run it at the beginning here. It initially just brings up a blank screen here, gray background, no balls yet. And that's what it does now. So it should run and have, we were to write stubs for its methods. We haven't yet constructed a ball, but it should not crash at this point. Now to make a ball, we come down here and somewhere in our initialization section, maybe after the clock, we will make a ball. So I'll call it ball 1. And we make a ball by the same way we've been making objects all along. To construct a circle, we type circle. To construct a ball, we type ball. Now, no RG dot because there's no Rose graphics here. And so far, when we construct a ball, we don't pass any information to it. Now, the init had no arguments. It objects to ball because it says there is no definition of the ball class or function or anything in here. So we come up here to our imports, and we say from ball with a capital B, import ball with a capital B. From the ball file, import the ball class. And that says, PyCharm, go off and look at the ball file. And when it does so, it'll come over here and it'll see, there's a definition of a class called ball. Doesn't do anything yet, but it's defined there. And so it can accept that it's okay to construct one. Run if you haven't already, and confirm that it doesn't crash, just brings up a blank screen. If you have questions during this Follow Me, be sure that you address them to me outside of class, but I hope that you'll that this will be clear enough for you. So that constructed a ball object. Now the next thing we're to do, that was to do 1. Make the ball appear on the screen. So to do that, well, first of all, the ball is going to appear on the screen. To make that happen, we need to get the screen to the ball. There are 2 ways we could accomplish that. In the draw method that we're about to write, we could pass the screen as an argument, or what we'll do here, in the constructor method, the underscore, init, underscore, we'll send the screen and let the ball store the screen so it has the screen and can use it for drawing, for example. So there's constructing a ball, and let's see here. And we're now in the process of drawing it. So let's go back here. We're making the ball appear on the screen. So we did that. Since we put screen there, we need to go over to the ball class and put screen in here. And then store screen in a self variable, self screen equals screen. So that stores with the ball itself its screen on which it can draw. We can then come over here to the draw method. Now this is going to be a Pygame thing, so we better import Pygame. And then we can come down here and try to remember how to draw circles. Pygame.draw.circle. And it fills in what we need there. Let's see. We need a surface, color, center, radius. We'll do without the width and these other optional things. They're optional because of that equal sign there. That's what makes them optional. So let's see here. Let's put the screen in. So there's the screen. And, oops, self.screen. So self is an argument to draw. So we're allowed to refer to self, and inside that, the variable screen, the instance variable screen. And let's see, we also need to have the position and other things. So let's make some variables for them. For now, I'm just going to make them here and assign them arbitrary values. So I'm going to make a self X, that's 100, self Y, that's 100, self color, that is, let's make it a Pygame.color. We'll make it black for starters, or maybe red. I don't know. Let's make it red. And self radius, we'll make it 30. So there's some initial values, and then we can come and use those initial values down here in the draw. So we put in the self color. The center is self X, self Y as a pair of things. And we can make that either a tuple, which is what I will do, or a list. Doesn't matter. And then there's the self radius. So when we come back here to bouncing ball, if we were to run, nothing exciting happens yet. So let's just run to be sure we haven't made any typos. But no ball appears yet because we haven't told the ball to draw itself. So that's the drawing section. So we come down here and tell ball 1 to draw itself down here. When we run now, we see our ball. So if you had troubles with any of that, either I'm going to review what we just did so that you can see it all, and then make sure you have that right before you continue. Just reviewing here, we have our starting code. We created a ball with the screen. We drew the ball, and up above, from ball, we imported ball. I think those were the 3 lines we did here. And then in the ball class, we did this, which had the init, draw, and move methods. Again, pause the video and get that straight if you're having any troubles. Continuing from there, we go back to bouncing ball, and it says next to make the ball move. So to do that, we go back to the ball class. To make it move means changing its x and y coordinates, because that's where the ball is drawn. So if we change those values, then they'll be drawn at a different place. So we say self.x equals, we could use a plus equal if you prefer, self.x plus, and we'll use a speed in the x direction. Let's see. Actually, I'm going to check here real quick. In my solution, we'll just use a speed. Yes, a speed variable, I think. No, speed x and speed y. So we'll have, I'll call it speed x and speed y, like I did in the solution. Speed x, self y plus self.speed y. So make sure that you get that right. Speed x, speed y, however you spelled it there, spell it the same way up here, where we initialize self speed x to, say, 3, and self speed y to, say, 5. So make sure you have that. Initializing them, making it move. And then back in bouncing ball, we have to tell the ball to move. So after we, so every cycle, we want it to move. So this will occur before it's drawn. It'll move and then be drawn. And we just tell it to move. No self, despite me having typed it there. It's called ball 1 here because the name of the ball is ball 1. Inside the ball class, it's called self. Outside of the ball class, it's whatever the variable name is, ball 1 here. So ball 1 move makes the move method in the ball class run with self set to ball 1. Let's run and see if it seems to move, and there it is moving. It doesn't bounce yet, but it moved just fine. Let's run it again, make sure that we're okay, and there it is. It's convenient to use the little green triangle, green arrow thing, so that, because if we switch back and forth between files, we're always running the same thing, which is the one that came as main. So we've done making it move. Next is to make it bounce. So let's do that. So we want to make the ball bounce. To do that, we come down here, and let's go off to the ball class, I guess. And we'll make another method, which I'm going to call not bounce, but bounce if off screen. Bounce if off screen, to indicate that this bounces, but only if it's off screen. Now, to be off screen means either its x value is negative, because that's off to the left, or its x value is bigger than or equal to the screen's width, which we can use self_screen.getWidth to get. And if that's the case, we want to reverse it. If you think about it, reversing it means not changing the x position. To reverse its direction doesn't change x. It changes speed x. And to reverse it means to change speed x to negative speed x. Self speed x equal negative speed x. And then independently of that, the same thing but with y and the height. And if so, the self speed y equal negative self.speed y. So take a moment and get bounce if off screen right. Pause the video if you need to. And then once you have that, Go on back here to M1 bouncing ball, and after it moves, tell ball 1 to bounce if off screen. And when we run, it should now bounce, and there it is, bouncing happily. Again, all we did was told it to bounce if off screen in main. And over there in the ball class, we made this bounce if off screen. It says if self x is less than 0 or self x is bigger than or equal to self screen get width, change self speed x, not x, speed x, equal to, not minus equal, but just equal to negative self speed x. So if it was a positive number going at speed 3 in the x direction, it's now a negative number going in the opposite direction. So that was this one here, make the ball bounce. So we've achieved a great deal with not much code. Now it says to construct 2 ball instances instead of just one, initially on top of each other, and then we're going to make each ball start at a random place with a random color, random radius, and a random speed. We'll do those one by one. So let's go here and first construct 2 balls initially right on top of each other. So that's back in main. So there's ball 1. And ball 2 will be a ball. And it's gray because we haven't done anything with it yet. We have to, down here, tell ball 2 to move. And ball 2 to bounce if off screen. And then when we run, nothing exciting happens. We get there are actually 2 balls, so they're on top of each other, so we can't see that. They're both at the same x and y, same speed, same color, everything. So it looks as if there's 1, but there's in fact 2. Now, to make them at different positions, we're going to go up here and put them at random x and y positions. So instead of x being 100, we're going to make it a random place. So let's import the random module and set x to random dot randint, and we'll choose a place between 0 and the screen width -1, I think, because randint, if I remember right, is in the range A to B. It includes both endpoints. So screen's width is the arguments, the value for the x and y go from 0. So screen width -1 is the right edge. And then similarly for self y. Using height, of course, for y. And I think if we now run, we, don't have 2 balls yet because I forgot back there in bouncing ball. So here we just changed x and y to be random numbers. Back in bouncing ball, we made ball 2 move and bounce, but I forgot to make ball 2 draw. So we need to put that in there. And so now we have 2 balls. They have the same color and the same speed, so they're sort of glued to each other there, but they start at different positions. If we run it again, they may be separated by a little different amounts, but they're moving along. They're at random initial positions. So there we go. Again, if you have questions, just offline, reach out to me, please. Random color. Well, go back to the ball class. Where's that color? So what we're going to do is do self.rand. Well, let's see. Colors are 3 tuples. So Pygame. No, let's see here. Colors will be 3 things in parentheses. a random randint between 0 and 255 for the red, and then a random amount for the green, and then for the blue. So random amount for red, green, and blue. So self-color, which is used in the drawing, is now assigned randomly. And it's set to a tuple, so those parentheses are important. We then run it here. We have random colors. Continuing with our iterative enhancement plan, going back to bouncing ball, we're to make him have a random radius within some range specified by parameters that are in init. So we're going to make a maximum and minimum for x. I'm going to look briefly at my solution to choose the same names I chose in the solution, just for consistency. Not there. I'll call them min radius, max radius. 10 and 40 is what I'll initialize them to. Okay. So I go over here to ball, and my radius, what I'm going to do is I'm going to make a couple of variables here. Self dot a min radius. And I'm going to actually send this value in, I think. Yes. So I'm going to have the min radius be an argument. I could have done it otherwise. And I'm going to set it equal to 10. So I'll give it a default value of 10. So we don't have to specify the min radius. It can default to 10. And likewise for our not radius, they should have been, yes, min radius equal 10. Max radius equal, I'll do 40. And then self min radius is equal to that argument radius, and self max radius equal the maximum radius. And self radius becomes a random dot randint between the min radius and max radius. I think I got it all there. Let's try it out. So when I run, yes, there seem to be random colors and now also random radii. There we go. And they're currently using the defaults 10 and 40. Let's change so that ball 2 doesn't use defaults for its range of its radii. So ball 1 will use 10 and 40, the default values, but ball 2 is going to be somewhere, we'll make it a big ball. It's somewhere between 30 and 50. So there's ball 2. While we're at it, I'm going to make my screen a little larger because we're going to end up with more and more balls. Or maybe I'll do that at a little later stage. I think that's in our plan. Yes, screen bigger is in the next step, so I'll wait with that. So we made the random radius. That was these two here and these lines. Notice the equal signs there. That says there's a parameter here, min radius, that is optional. So in the construction of the ball that calls init, you can either have a value for min radius or not. In the way you notate it, if you do, one way to notate it is you say the name of the variable. I didn't even do that. I'm going to do it here. Min radius equal 30. Max radius equal 50. So I could have left those out, but I put them in there so that I could write them in any order that I want. So by putting the names of the variables there. So if you haven't already, be sure to go back there and put in min radius equal 30, max radius equal 50. It's a little hard to read there in my color scheme. Let's switch my color. Well, but there we go. Min radius equal 30, max radius equal 50. The next thing that we're to do, oh, and I need to run that. There we are running it, and the big one is that size there. Let's see if now the ball 2 is in a different range. It's between 30 and 50. It should always be between 30 and 50. Doesn't look very random. There we are. Min radius, max radius, random between min and max. Yeah. Not sure quite why that's visually so little different between 30 to 50. Yeah, it is different each time. So somewhere between 30 and 50. And the first one between 10 and 40. Maybe I should have made that a little bigger just to give it more of a range. I think I'll do that there. Yeah. So now the big ball might be quite big or not as big. So I just changed the max radius of the ball 2 to be 100. You're welcome to change that or leave it there. Alrighty, so the next thing to do is to make a random speed within some range specified by init parameters. So I'm going to cheat and just go off to the solution because I want to do it just like I did in the solution. And I'm afraid that if I just try to remember, I'm going to forget. So here are the relevant lines there. I'm going to paste them. You can copy and paste too if you'd like from the solution, or you can type, your choice. So then I'm going to close that. Come back to the ball class. And I'm going to make a min speed and max speed. So min speed. Let's see, again, I want to choose the same things as I chose in the solution. So I'll choose min speed to be between 1 and 8. So min speed will be 1. Max speed will be 8. And make it a little more readable. And then what we have down here is instead of self speed and self speed x being 3 and 5, so I wiped out that 3 and 5. Make sure that you delete that. 3 and 5 went away. I said use random.choice, which picks a random number from a selection given it, -1 or 1 in this case. So the direction is either negative or positive. The amount that we are above min, well, I want this to be a floating point number. So I'm going to pick a number between 0 and 1. That's random, paren, and multiply it by the range, max speed minus min speed. So this is the amount above min, and we take that amount above min and add min, multiply it by direction to get the speed in the x direction, and then similarly in the y. I'm going to run and make sure that that gives random speeds. And they seem to be moving at different speeds there. And there they are. So now doing different speeds, different colors, different starting positions, different radii. The radii are within a user-specified range. User-specified meaning that the code that constructs the ball can say what the range for the radius is and can say what the range for the speed is. The x is just a random point on the screen, and the color is just a random color from all colors possible. Again, if you have questions, please just write down your question and reach out to me offline. Back to the ball class, getting rid of the solution there. Back to the ball class. back to main. We've done number 5. We're now ready to do number 6. Number 6 says make a list of 10 ball instances that all move and draw, and make the screen bigger, 1000 by 650 while we're there. So let's go back to the screen size here. What was it? 1000 wide by 650 tall. So having global constants there isolates where we make those changes. So an error-prone practice, but handy for small programs like this. We use all caps to symbolize them. And then after ball 2, I'm going to make a bunch of balls. So to make balls, I need a loop. So for ball in, I want to make a bunch of balls. I'm going to make 10 of them. For K, for underscore in range 10, so I'll make 10 balls. I'll say ball, need to make a list here. So I need to make a list of balls and then loop through. I'll make 10 balls there. Whoops. Balls equal the empty list. And then I want 10 balls. And so I'll use the variable underscore traditionally used when we don't need it to use it here inside the loop. And I'll say ball equal ball on the screen. And I'll use the defaults, I think, here for the radius and speed. And then balls, plural, append that ball. So we made a list of balls, and we put each constructed ball into the list. And we come down here to the various things, and we loop through them. So for ball in balls, ball dot move, and likewise for ball in balls, ball dot bounce if off screen, and finally for ball in balls, ball dot draw. So I just go through each of the balls in the list and move each one, and then bounce each one and draw each one. Make sure you get all 3: move, bounce if off screen, and draw. So I should see now more balls on a bigger screen. So there they are. I should have, I guess, 12 balls, 10 that I just created plus the original 2. So there they are, various colors bouncing around. Test to see that I get something different when I run again, and that does look different to me. So the next thing, that's a list, is to make a balls class. So since we have these 3 places where we do things to all balls, and in a bigger project we would have other things that we do to the collection of balls, it's handy, not required, but handy to make a balls class. And you'll find that's true in your project as well, that you'll have multiple instances of something or another, and you'll want both a singular of that class and a plural. You're almost bound to want that in your project. So I'll come up here, right-click on SRC, and make a new Python file, and call it balls, plural, with a capital B. I'll add it to Git. And if you forgot to add it to Git, you can do that later when you commit and push by using the Git menu and just do a manual add. So I'll make a class balls, plural. I'll make an init that takes the screen and sets the screen to screen. And I'll make, for now, what do we have here? A draw that is just a stub for the moment. A move that is just a stub. and a bounce if off screen that is just a stub. So just stubs so far. I'll run to make sure I haven't made any typos. So no changes to the code here because I haven't made a balls instance yet. And then back to main, it said to make a balls class that stores its own ball instances. And I'm to make 2 ball instances. And ball instances are supposed to be able to have slow and big or small. So I'll go back to my balls class, back to balls, and in addition to screen, I'll have a min radius, a max radius, a min speed, and a max speed. Min radius, max radius, min speed, max speed. And to construct a balls instance, I also need to know how many balls to make. So after screen, but before those radiuses, and I'm going to put in defaults for those values. I'm going to look back to my solution to see what I used as the defaults there. 10, 40, 1, 8, just like I did in the other. So balls 10, 40, 1, and 8 for the default values. And now I need to have the number of balls. So I squeeze that in after the screen, but before the min radius. Number of balls. And then I'm going to use these things by saying that, let's see, I'm going to make a self.balls variable. That's the list of balls. And then for variable inside range number of balls, I want to construct a ball object using those values for min radius, max radius, and so forth. So ball equal a ball on the screen. Whoops. And I'll need to go up here and say from the ball class, import the ball from the ball file, import the ball class, from ball, import ball. Then I can say ball equal ball with screen, min radius, max radius, min radius, max radius, min speed, max speed, min speed, max speed. So when I construct a balls, plural object, I can either use the default values for the radii and speeds, or I can use my own ones. So let's continue on here while we're in here. So then drawing is very simple. It just loops through the ball objects and self balls and tells each one to draw itself. Go ahead and write that code yourself. Give you a few seconds to be thinking ahead of me. Loop through the self.balls for ball in self.balls and tell each one to draw itself. Ball.draw. Go ahead and do move similarly and bounce if off screen similarly. There we go. Now, if I run, nothing exciting happens because I haven't constructed a balls instance in main, but it shouldn't crash. So if yours crashes, you have some typo, and you should look back to here to see what's up. Back in main, I'm going to create, what does it say to create? 25 slow big ones, 75 fast small ones. I'm going to look back to my solution to use the same constants that I used elsewhere. I'll just copy those 2 lines. You can do similarly if you choose, or you can write them. So bouncing it back in the M1 bouncing ball in main, after making my explicit list, I'll make two balls objects. I'll need to have an import here from the balls file, import balls class. And then down here, slow balls are balls on the screen. And I'll have 25 of the slow ones, 75 of the big ones, of the fast ones. The slow ones will be big, between 15 and 50, and the other ones, the fast ones, between 12 and we'll just have a max radius of 12, and we'll use the default min radius, which I think was 1. No, it was 5, I think. I've forgotten. And then min speed between 5 and 25 for the slow one, for the fast ones, and the slow ones, just a max speed of 4. Min speed, if I remember right, defaults to 1. And then I can come down here and for a ball in slow balls, ball.move. Oh, let's do it this way. For ball in slow balls is a list. No, slow balls is an object. I'm doing this wrong. Sorry. And we come down here, and slow balls, we don't have to write a loop because slow balls has the loop as part of its code. So we just tell slow balls to move and fast balls to move. And see, slow balls itself, look at the balls class, that's internally stores that list and loops through the list to move them all. So the advantage of this approach is that we don't have to keep writing these little loops here. We can just encapsulate the loop in a single thing there. And so we can say the slow balls dot bounce, fast balls dot bounce, and slow balls dot draw, and fast balls dot draw. I'm going to run to make sure I'm okay here. And there they are, and they're moving around, and I think we have, doesn't look like the right number of them. Let's see. Oh, I failed to put it in the list. So, sorry. See how it says this variable is unused? Unused. So go back to the balls file in class, and having constructed that ball, I need to tell self.balls, the list, to append that ball, put it in the list. Right now the list stayed empty, so nothing was done. So this was the missing line. Let's run and make sure that works okay. There we go. 75 small ones, 25 big ones that are slow. Run again to be sure I get something different. Hard to say, but they are, in fact, different. So I think we've got it there. Certainly getting different sizes for the slow ones. Fast ones all look like they're not. Well, I guess they're random. The fast ones are speeds. Are sizes from up to 12 is the maximum radius. And the min radius was 10. So that's why they're all so similar. It's from 10 to 12. So they look quite similar. Okay, so I think that does it, polishes it off here. I'll leave to you to make a scoreboard if you choose. No need to do that unless you want to display the number of bounces. But if you're looking for a challenge, that's something you could do. And in your project, you'd certainly want to make a scoreboard if you were doing something like this. So again, if you have questions, come back to me. I'm going to reach out to me outside of class. And also, if you're just having troubles tracking down some error, you can just look at the solution and do a diff. So you can do things like this. Select that and select that. I selected both of them. Right-click, compare files. And the differences should be fairly minimal. Looks like I did things slightly different there. Put in a blank line there. Bouncing. So when I did the solution, I did it differently. Instead of calling bounce separately, I put bounce as part of moving. So that was probably a better solution. That move called the helper method bounce if off screen. Then I didn't have to have any calls to bounce if off screen because I just moved them. So that was a superior solution. Well, hope you enjoyed that. Bye-bye.